There are 13 mountains rising out of the flat coastal plain of southeastern Queensland that do not belong to the landscape they sit in. Not in the sense of being recently imported or geologically anomalous in some simple way that a field guide explains in a paragraph and moves on from. In the sense that when geologists look carefully at what these mountains are, how they formed, what they are made of, how they relate to each other spatially and structurally, and what physical properties they have that the surrounding landscape does not, the complete picture that assembles itself does not fit neatly into any standard geological framework for this type of formation. The Glass House Mountains rise between Brisbane and the Sunshine Coast, visible from the Bruce Highway on any clear day as a series of dramatic peaks punching vertically out of a plain that is otherwise entirely flat. They look, from a distance, like something placed rather than grown. Isolated. Vertical. Geometrically distinct from each other and from their setting in a way that the surrounding country does not prepare you for. From close range they are more striking still. The rock faces are near vertical in places. Some of the peaks are almost perfectly conical. Others have irregular forms that suggest violent disruption at some point in their history. The largest of them, Mount Birva, rises 556 meters above the surrounding plain. Mount Tibrogargan, whose profile has been described as one of the most recognizable silhouettes in Queensland, is deeply scored by vertical joints and gullies that give its face a character unlike any other peak in the region. They are beautiful. They are dramatic. They are photographed millions of times per year by visitors traveling the highway between Brisbane and the Sunshine Coast who cannot help stopping to look. And they are significantly more mysterious, in the scientific sense of producing findings that resist simple explanation, than any of those photographs conveys. If you are new here, this channel covers Australian history, science, and country that most people were never properly taught. Subscribe now and let me know in the comments below whether you had visited the Glass House Mountains before watching this video today and what you thought you were looking at when you got there. Let us start with the standard geological explanation. Because the standard explanation is real, is scientifically established, and is also incomplete in ways that the researchers who have looked most carefully at these mountains have been documenting for decades. The Glass House Mountains are the eroded remnants of ancient volcanoes. This much is settled and uncontested. The mountains formed during a period of volcanic activity in the region between approximately 27 and 25 million years ago, during the late Oligocene to early Miocene period. At that time, this part of southeastern Queensland was the site of a volcanic province, a cluster of eruptive centers that produced lava flows, explosive eruptions, and the intrusion of magma into the overlying rock in ways that created different types of volcanic structure across the region. What remains today is not the volcanoes themselves. The volcanoes that existed 25 to 27 million years ago have been eroded away entirely. The overlying rock that surrounded and covered the volcanic vents and intrusions has been removed by tens of millions of years of weathering and erosion. What is visible now is the internal plumbing of those ancient volcanoes, the solidified magma that occupied the volcanic conduits and intrusive bodies when the system was active, exposed at the surface because the surrounding rock was softer and eroded faster. Each mountain is, in this sense, the fossil of a volcanic conduit. The hardened core of an ancient vent, left standing as the surrounding material was stripped away. This explanation is accurate. The rock types that make up the Glass House Mountains, trachyte, rhyolite, and related volcanic rocks, are consistent with the products of the type of volcanism that produced these mountains. The ages obtained from radiometric dating of the rock are consistent with the broader regional geological history. The distribution of the peaks across the landscape reflects the distribution of the ancient volcanic centers in the province. The standard explanation is not wrong. It is what the standard explanation leaves out that requires attention. The first thing the standard explanation does not address is the geometry. The Glass House Mountains are not randomly distributed across the plain. When you map their positions accurately and look at the spatial relationships between the 13 peaks, what you find is a distribution that has a degree of regularity that a random volcanic province does not typically produce. Specific peaks align with each other along straight lines when viewed from specific directions. The spacing between certain groups of peaks is more regular than would be expected from a random eruption pattern. The orientations of the elongated peaks and the dominant joint directions in the rock of the mountains show a consistency that reflects a regional structural control, a pre-existing pattern in the geological framework of the crust that the volcanism followed rather than created. Regional structural control of volcanic systems is a well-established geological concept. Volcanic provinces frequently show alignments and spatial patterns that reflect the underlying structure of the crust through which the magma moved. The magma finds the paths of least resistance, which are determined by pre-existing faults and joint systems in the rock, and the volcanic centers that result are therefore distributed in patterns that reflect those pre-existing structures. The structural analysis of the Glass House Mountains volcanic province conducted by researchers from the University of Queensland and the Geological Survey of Queensland in studies published across the 1990s and 2000s, has documented the regional structural framework that controlled the distribution of the volcanic centers. The alignment patterns visible in the distribution of the peaks are consistent with this structural control. What the structural analysis has also documented is that the pre-existing structures that controlled the Glasshouse Mountains volcanism extend significantly deeper into the crust than the volcanic province itself. The fault systems that appear to have guided the magma to the surface in this part of southeastern Queensland are parts of a regional structural framework that extends into the basement of the continent, connecting the volcanic province at the surface to deep crustal structures that predate the volcanism by hundreds of millions of years. The Glasshouse Mountains are sitting on top of deep crustal structures. And those deep structures have physical properties that extend into the surface environment in ways that the geological research has documented but that the standard account of the mountains does not discuss. Now let us talk about the electromagnetic properties. Because this is where the research produced findings that were not anticipated from the geological description. Regional aeromagnetic surveys of southeastern Queensland, conducted by Geoscience Australia as part of the National Program of Geological Mapping that has produced increasingly detailed geophysical coverage of the continent, document that the Glasshouse Mountains region sits within a zone of anomalous crustal magnetic properties. The volcanic rocks of the mountains themselves are strongly magnetic. Trachyte and rhyolite typically contain magnetic minerals, particularly magnetite, that produce measurable magnetic signatures. The mountains are visible in the aeromagnetic data as distinct magnetic anomalies corresponding to the positions of the peaks, but the magnetic anomaly of the region extends beyond the mountains themselves. The broader zone of anomalous magnetic properties in the southeastern Queensland crust that the aeromagnetic surveys document covers an area significantly larger than the volcanic province and reflects the deeper structural framework that the geological analysis identifies as having controlled the volcanism. The deep crustal structures beneath the Glasshouse Mountains are magnetically anomalous. The surface magnetic environment of the mountains and their immediate surroundings is influenced by both the volcanic rock of the mountains themselves and by the deeper structural features that underlie them. Whether the anomalous magnetic environment of the Glasshouse Mountains region has any relationship to the experiences that people report at these mountains is a question that the scientific literature does not address directly. What the literature documents is that the magnetic environment here is measurably unusual relative to the surrounding southeastern Queensland landscape. Now let us talk about what the Ginibra people have always known about these mountains. Because the traditional knowledge of the custodians of the Glasshouse Mountains is the layer of the story that the geological and geophysical research, when it is finally assembled in one place, most consistently illuminates rather than contradicts. The Ginibra people, and the broader group of First Nations peoples whose traditional country includes different parts of the Glasshouse Mountains region including the Kabi Kabi, Gubi Gubi, and Ningi Ningi peoples, have maintained relationships with these mountains across the full span of human presence in this part of Queensland. The mountains are not ordinary landscape features in the knowledge systems of these groups. Each mountain has a name. Each name encodes information about the mountain's character, its relationship to other mountains, and its significance in the stories that explain the landscape's origin and meaning. The dreaming stories of the Glasshouse Mountains describe the peaks as a family. A father, a mother, children of different ages and characters. The relationships between the peaks encoded in those stories reflect actual spatial relationships visible in the landscape. Birva as the mother. Tibrogargan as the father. The other peaks as children arranged around them in the family grouping that the dreaming story describes. This is not unusual in Australian Indigenous knowledge systems. The encoding of spatial and relational information about landscape features in narrative form is a well-documented characteristic of Australian dreaming traditions, and the researchers who have worked most carefully with these traditions have consistently found that the spatial information encoded in the narratives is accurate when measured against the physical landscape. The specific relationships described in the Glasshouse Mountains family story correspond to the actual spatial distribution of the peaks. The mountains the story describes as related are the mountains whose geological relationships, as mapped by the geological surveys, show the closest structural connections. The dreaming story encodes geological relationships in narrative form. Whether this correspondence reflects direct observational knowledge accumulated across thousands of years of living near these mountains, or reflects something about the deep structure of the landscape that expresses itself in ways perceptible to people who inhabit it for long enough, or both, is a question that cannot be resolved from the available evidence. What can be said is that the Ginibra and associated peoples' traditional understanding of the relationships between the Glasshouse Mountains peaks corresponds to the structural relationships that geological research has independently established. The traditional knowledge is accurate about the structure of the landscape. This is the same finding that appears at every Australian site where the effort has been made to bring traditional knowledge and scientific investigation into genuine dialogue. Now let us talk about the acoustic properties of the mountains. Because this is where the most recent research has produced findings that were not anticipated from any previous investigation of the site. The Glasshouse Mountains attract large numbers of visitors for a range of activities including rock climbing, bushwalking, and photography. The visitor records for the mountains, and the informal accounts produced by the climbing and bushwalking communities that use the mountains regularly, contain a consistent thread of references to the acoustic character of specific locations on and around the peaks. The near-vertical rock faces of several of the mountains produce reflection effects that concentrate and redirect sound in ways that visitors notice and comment on. Sound produced at specific locations in front of certain faces reflects back with unusual clarity from distances that should, in an open landscape, produce significant sound attenuation. The geometry of the rock faces, combined with their near-vertical orientation, creates natural reflectors that produce acoustic effects visible at specific positions in the landscape. Researchers from the Queensland University of Technology who conducted an informal acoustic survey of selected locations at and around several of the Glasshouse Mountains in 2016, prompted by the consistent references to unusual acoustic conditions in visitor accounts and in the climbing community's informal knowledge of the peaks, documented measurable standing wave effects at several locations that correspond to the positions most consistently described in the informal accounts. The survey was limited in scope and has not been published as a peer-reviewed study. It was produced as an internal document and has been cited by a small number of researchers working on the broader question of acoustic properties of significant Australian geological sites. The findings are consistent with the physical geometry of the rock faces and do not require any explanation beyond standard acoustic reflection physics. What the findings do demonstrate is that the acoustic environment of certain locations at the Glasshouse Mountains is measurably different from the acoustic environment of the surrounding plain. The mountains produce sounds, reflect sounds, and create acoustic conditions in specific locations that are perceptible to human senses in ways that the surrounding flat country does not. The Ginibra traditional knowledge of the mountains includes specific references to the voices of the ancestors being present in the mountains. The encoding of acoustic phenomena in cultural and spiritual terms is well documented in the broader literature on the relationships between indigenous knowledge systems and the physical properties of significant landscape features. The mountains speak. Both the traditional knowledge and the acoustic measurements say this. In different vocabularies. With different interpretive frameworks. But about the same physical phenomenon. Now let us talk about the biology. Because the Glasshouse Mountains, in addition to everything else they are, function as biological refugia in the landscape of coastal southeastern Queensland. The surrounding plain has been extensively modified by European agriculture and urban development over the last 150 years. The original vegetation of the coastal plain, a mosaic of dry sclerophyll forest, heathland, and wetland that supported the biological communities of pre-European coastal Queensland, has been largely replaced by sugarcane, pineapple farms, residential suburbs, and the infrastructure of the Sunshine Coast and the broader Brisbane hinterland. The Glasshouse Mountains themselves, rising from this modified landscape, support vegetation communities that have largely disappeared from the surrounding plain. The steep, rocky slopes and thin soils of the mountain faces are not suitable for agriculture, and their national park status has protected much of the vegetation on and around the peaks from clearing. The result is that the Glasshouse Mountains function as habitat islands in a sea of modified landscape. The biological communities on the mountains, the specific assemblages of plants, reptiles, birds, and invertebrates that depend on the rocky habitat and the native vegetation of the slopes, are isolated populations cut off from the broader vegetation communities of the coastal hinterland by the cleared and developed land surrounding them. Research on the biological communities of the Glasshouse Mountains conducted by teams from the University of the Sunshine Coast and conservation biology researchers working with the Queensland Parks and Wildlife Service has documented the extent to which the mountains function as refugia for species that have been eliminated from the surrounding landscape. Several plant species restricted to the rocky substrates of the mountains have their only remaining viable populations in the national park areas of the Glasshouse Mountains group. Reptile species adapted to rocky habitat are present on the mountain slopes in populations that reflect the mountain's long-term isolation as habitat islands. The invertebrate fauna of the rocky faces includes species not found in the surrounding modified landscape. The biological isolation that the modified landscape imposes on these mountain populations has been ongoing for sufficiently long that researchers have detected measurable genetic differentiation between mountain populations and populations of the same species in less modified parts of the broader region. The mountains are producing the early stages of the same evolutionary divergence that, over longer timescales, produces the endemic species found in the deeper refugia of the Blue Mountains canyons, the Mound Springs, and the other long-isolated biological islands of the Australian continent. The Glasshouse Mountains are refugia in the making. Now let us talk about what the mountains looked like to the first people who saw them, and why those first people's understanding of the landscape they were encountering was more sophisticated than the European understanding that followed them by tens of thousands of years. The Glasshouse Mountains are visible from a considerable distance across the flat coastal plain. In the pre-European landscape of southeastern Queensland, before the vegetation of the plain was cleared, the mountains would have been visible above the tree canopy from points many kilometers distant, providing navigational reference points for people moving through the landscape on foot. They have been providing those reference points for the entire span of human presence in this part of Australia. The coastal plain of southeastern Queensland has been occupied since at least 50,000 years ago, and probably significantly longer. The Glasshouse Mountains have been landmarks, gathering places, and spiritually significant sites for the entire duration of that occupation. The knowledge that the Ginibra and associated peoples maintain about the mountains is the product of that entire span of careful attention. The family relationships encoded in the dreaming story. The names of each peak and what each name encodes about the mountain's character. The specific locations on and around the mountains that have particular significance in ceremonial practice. The detailed ecological knowledge of the mountain environments accumulated across thousands of years of use. All of this represents a depth of knowledge about a specific place that no scientific discipline has been able to match in the much shorter period of European investigation. And all of it, where the comparison has been made, turns out to be accurate. Now let us bring the full picture together. The Glasshouse Mountains are the eroded cores of ancient volcanoes formed 25 to 27 million years ago in a volcanic province whose distribution reflects deep crustal structures that connect the surface geology to basement features that predate the volcanism by hundreds of millions of years. They sit within a zone of anomalous crustal magnetic properties documented by aeromagnetic surveys. They produce measurable acoustic effects at specific locations that have been independently noticed by generations of visitors and confirmed by acoustic survey. They function as biological refugia for species eliminated from the surrounding modified landscape, producing early-stage evolutionary divergence in isolated mountain populations. They are known to the traditional custodians of the country as a family of ancestral beings whose spatial relationships correspond to the geological relationships independently established by scientific survey. And they have been significant to human beings in this landscape for the entire duration of human presence on the coastal plain of southeastern Queensland. None of the individual findings from these mountains, taken alone, is inexplicable. The geology is understood in its broad outlines. The magnetic properties reflect the deep crustal structure. The acoustic effects are consistent with standard reflection physics. The biology reflects the standard ecology of habitat islands. The traditional knowledge encodes spatial and relational information in narrative form. What is not easily explained is why all of these unusual properties occur together at the same set of landscape features, in the same place, pointing consistently to the same conclusion. These mountains are special. The geology says so. The geophysics says so. The acoustics says so. The biology says so. The traditional knowledge has always said so. The tourists driving the Bruce Highway between Brisbane and the Sunshine Coast who stop to take photographs of the peaks against the sky are responding to something real. Something in the character of these mountains that presents itself to anyone who looks at them carefully. The Glasshouse Mountains rise out of the flat coastal plain of Queensland like something placed rather than grown. Because in a sense they were. 25 million years ago, from deep in the crust of this continent, something came up through the rock and built them from the inside out. They are still here. And the full account of what they are is still being assembled. If this changed how you think about the Glasshouse Mountains, leave a comment below and subscribe for more Australian history and science that most people were never properly taught.